Okay, it's figured out how to record while showing something on the projector, while talking and while annotating all at the same time. It was pretty complex, but hopefully it works out. So that's what's going to happen. Second announcement, when you are in class, when we were doing virtual last week, we essentially met from 8:45 and then it was with a 15-minute break only in between. We did it until 11:30. And then the last hour was like an asynchronous, you're supposed to study by yourself sort of kind of a period, right? Up to 12:30. Now that we are meeting in person, you are responsible to stay with me from 8:45 till 12:30. So you can imagine there's going to be two breaks in between, okay? And we technically have slots for 3 lessons. What I'm still going to do is keep to our normal style. I am going to give you 2 lessons, maybe a little bit more lax and spaced out, and the remaining time that we have is going to be open floor, tutorial, Q&A, homework period, whatever, but you are responsible to stay with me till 12:30. Any questions? None? Yeah, this was sort of all thrown at me last minute. Like I totally didn't know about the signing in thing. No one gave me the resources, but now I do. So you guys gotta keep up with me. Okay? Concerns, comments, anything? None? All right, sounds good. All right, let's get started. Um, I'm gonna ask maybe 3 or 4 people their opinion or their suggestion how they decided to group these relations. Okay, first tell me how you group them and then tell me the reasoning. Let's start from bottom up this time. Zoe, how did you decide to group these?
I really don't know.
Okay, not a problem. It's just based on your criteria, how would you group them and why? That's it.
Um,
Ian, do we still sign in during days we don't have you in the morning like today? No. Today I do the attendance with you, so that's not a problem. It's only on those asynchronous days. Let's see. But you know what, Zoe? Even if you're not sure, give me one criteria you could use. Like, let's say you were the first mathematician. How might you group these based on their differences?
maybe linear and quadratic, and then other.
Okay, so A and B together, they are considered what we call functions. Why are C, D, and E and F another category? Like, what makes one a function, what makes one not a function is what I'm trying to get everyone to think about. Okay? So think about it. I'm going to go out to someone else. Random choice. Waylon, if I were to ask you to categorize these or group them into bundles, what might you use to distinguish them?
I'd use just like how they look. So B and D look pretty similar.
Okay.
Just one's turned on its side,
Okay.
and E and F look kind of similar, just turned on
Okay.
its side again.
Okay.
So I'd maybe group group those two together, and then just have A on its own and C.
Okay. So that's a lot of groups. If I were to
Yeah.
ask you to do one versus another, so in other words, there's group one and group two. You're only allowed 2 groups. How would you group them? Someone else. So keep thinking, Waylon, keep thinking. If I only allowed you to have 2 groups, how would you group them? Saima, what do you think?
I think I would have A through D as one group, and
Mm-hmm.
then E and F
Mm-hmm.
as a second group. I would consider E and F functions. I don't know why they're just like super squiggly.
Okay.
So
So wavy, squiggly, that's your criteria versus not wavy. So the more wavy it is, the more it's a function, basically.
yeah,
Okay. Okay. So function. Okay, something about that word makes me feel or makes Saima think that it's supposed to be wavy. Okay, somebody else. Patrick, you with us? What do you
Yeah,
think?
I'm gonna have to pass. I don't really know.
Okay, well, if you had a criteria and you only had to group it to two groups, what would be your description for group one, and what would be your description for group two? Patrick?
I would probably do the same, wavy and not wavy. That's only
Okay, that's fine. So for you, function might mean wavy. Okay. One more person. Louisa?
I really don't know.
All right. Um, so the word function is not closed and open. Might be okay. That might not be a bad criteria. So A, B, D, E, and F are all open, and then C is closed. So maybe a function means it's not closing in, it's not touching each other. Maybe, right? To get on with this course, which is called functions, we're gonna have to, number one, define what a function is, and then two, just how to get by using them in a variety of different ways. Let me put it this way. In mathematics, essentially, a relation is any connection between x and y, right? Relation as in relationship. Kinda asked, does it have to do with how many times it intersects with the x-axis? Possibly, right? That might be one way you can distinguish it. Like this one, it only crosses the x-axis once. This one does it twice. This one does it twice. This one does it once. This one does 1, 2, 3, 4, 5 times, or it could be more, right? There's so many different ways we can try to distinguish this. But again, going back, a relation is another way of saying a relationship. There is a relationship between x and y. For example, if x was the amount of hours you worked and y is the amount of money you make. Well, isn't that nice? You work 1 hour, you make this much. You work 2 hours, you make more. You work 3 hours, you make more. You get the point. It's a relationship. Same with here. I don't know what the relationship of this could be, but let's just say when x is a certain value, you get a y, right? Same with it. If an x is a certain value, you will get a y value right here. All right, that's why every single time I have an x, it's partnered with a y. Every time I have a value of x, it's partnered with a y, so on and so forth. Okay, so we've got people starting to chime in and give me their suggestions. There's a lot. Okay, Noam, are you copying this down from somewhere?
No, I already knew it.
Oh, I see. Yeah, so we're gonna get to this thing called the vertical line test. So a relation is any connection between x and y. Long story short, all of these red lines show a connection between an x and a y, an x and a y. But in mathematics, we don't want an ambiguous answer. The whole point of using math is if you give me some kind of info, you give me that, I will calculate something, I will compute something, and I will give you an answer. I will give you a result, right? I will give you a effect. Essentially, if you give me a cause, like science, I will give you an effect. A simpler way of saying is, if you give me some kind of value, I'm going to give you some kind of value. If you give me an X, I am going to give you a single answer. In other words, if you give me an X, I will give you the exact value of Y. I might have missed saying it. Long story short, a relationship is any relation, any connection between X and a Y. A function, a proper relation used in mathematics, a function is when You're given an x. For every x that you give me, there is only one y value possible. Let that sink in. I'll say it one more time. Anytime you get an x, for every x you have, it could be a 1, it could be a 2, it could be a million, I don't care. There is only one possible y value. There's only one possible answer. There's only one possible partner. What does that look like visually? It looks like this. If my x was a 1, that's my y value. If my x is a 2, that's my y value. If my x is a 3, that's my y value. Anytime you get an x, there's only one y. Same with the parabola. If my x is a -2, I have only one possible y value. If my x is a 2, I have only one possible y value. Take a look at C. If my x is a 2, my y value could be here, or it could be here. Visually speaking, what that could be is if an x value produce 2 points on curve, it's not a function. Okay, we're going to go through this one more time, but let me erase this and let's group them. So with that definition, is the following a function or a relation? Okay, someone brave, someone who's been following. Ian, just why don't you lead us then? Okay, the first one, is it a function?
Yes.
Yes. The second one, is it a function?
Yes.
Yes. Third one, is it a function?
No.
No, it's a relation. How about E?
D, I do not know because Noam's answer has thrown a bit of a curveball for me with the whole line test. So I'm just going to put a question mark for now.
Okay, how about E?
E, I also do not know.
Okay.
And I would say same with F, but Noam seems pretty confident, so I was going to say that is also a function.
Let's
Or
put it this way.
Only relation. Sorry.
For every x, there can only be one y. Let's do this. When x equals 0, what are the possible values of y? Yeah.
Well, there's only one and there's two y-intercepts, so.
Yeah, so for x, let's pretend that's 1, 2, 3, 4. When x equals a 0, y could be a 4, or
And
y
like
could
-2.
be a -2. Because there are two possible y values, this entire thing is simply a relationship. It cannot be considered a function. Okay, let's do it one more time. How about this one?
That one, let's take x is equal to 0.
Okay.
Y only has one.
Yep, it's only one point,
function.
so it's a function. Or if you did x equals 1, y is something. If x equals 2, y can only be one value. In short, you can say that this is a function, and under that same idea, take a look. If x was a 0, y could be this, 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 or this. It is a relation. I'm going to get to this thing called a vertical line test, but I guess it's nice to show. Take a look. An easy way to test whether something is a function or not is to, if you have this piece of paper, draw a straight line. Draw it as many places as you can and ask yourself, does this straight line touch this curve in more than one location? I think you get what I'm saying. I'm just making this into a big mess. I'm going to clear this and let us all go to our handout for today. Okay. Oh, of course, when my computer crashed, that thing closed as well. So let me pull that out. So today's lesson or today's little handout is 1.1. Hope everyone's still following. It's loading. There it is. All right. All right, here it is. Okay, so function versus relations. This is the intro to this entire course because the course is called functions. We're no longer considered relations. We want to talk about functions because, as I said, to use math in a variety of different areas in life, we want to make it so that it's useful. Like if you put in a piece of information, you want to get out a piece of information, right? You only want one answer. You don't want to be ambiguous. That's not helpful. So let's do this. What is a relation versus a function? In short, if you're filling this in with me, go ahead. A relation, aka that's why we call it a relation because it's a relationship, associates two sets of numbers together in any way I want. Like for example, let's pretend time is X and money is Y. If I work 0 hours, I guess I earn zero money. Let's say a student worked 1 hour, and I don't know what minimum wage is. Let's pretend they earned $20. But another person works for, I don't know, they do amateur coding or something, and they get like paid like $40 an hour, right? And that's great. Whatever. Another person works 3 hours at Shoppers Drug Mart as a box boy, and they get paid, minimum wage. They make $45, and one person, has a part-time job after work. They're a grocer. They work 6-hour shifts, and they earn, I don't know, $100. If you translate that on a graph, that's a 0. That's 1, and let's pretend that's 10 and 20. Right? That's a 1 with 10 and 20, 30, 40. Another person member worked 1 hour and $40. One person worked 3 hours and earned $45. Another person worked 4, 5, 6 hours and earned 50, 60, 70, 80, 90, $100 in that one day. This is a relation. And strictly speaking, I can say it's a relation because it does not pass the vertical line test, which I'm going to get to in just a second. Don't worry if you missed what a vertical line test was. Okay? A function is a special, you know what? Don't worry about this. Okay? If a function is a special relation where there is only one y value for every unique x value. I'm going to clear this screen and make another graph. Any questions with the relation portion? Going once? All right. So a function is a special relation where there's only one y value for every x value. So if I were to have the same relationship, time, money, I work 0 hours, I earn 0. I work 1, let's say I earn 20. I work 3 hours, I earn, I don't know. Let's say I get a bonus, I get 70. And I work 5 hours, I get another bonus, I get like 120. I don't know, right? But if it's at 0, 0, at 1, that's 20. At 2 and 3, 30, 40, 50, 60, 70. It would be like here. And if I work 5 hours, 80, 90, 100, 110, 120, something like that. And as you can see, again, I'm going to refer to this vertical line test. No matter where I draw my vertical line, it only touches the dot once. There is no overlapping like double dot or something like that. And let me get to the vertical line test, but I'm just thinking you're probably getting the hang of what that means. All right? So sometimes you will have complicated graphs, right? Sometimes you'll have very simple graphs. But regardless of what graph you have, you can quickly check whether it's a function or not by using something called the vertical line test, or you can just say VLT. If you have your piece of paper in front of you, you have a ruler, or a nail file, or anything straight, literally put your vertical object, your pencil, whatever, on the graph and see if this vertical line will touch the graph twice or more. Let me give you an example. I'm going to clear this screen. Just want to double check that I'm recording. Okay. So the first three are functions and the last three are relations. I'm going to take a red line. Take a look. If I were to draw vertical lines anywhere on the graph, here, let me see if I can move this. If I take this vertical line and put it anywhere on this graph, it will only touch my graph at one location at any given time. With me? This is considered a function. How about the next one? Let's say I draw a straight line and I move this all around to see touch only once, blank, 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 touch only once, touch only once, touch. There's no point, there's no location on this graph, or scatter plot rather, where this vertical line touches more than once. This is a function. Same with the parabola. A parabola that you've been working on since grade 10 is a function. No matter where I move this vertical line, it will only touch the function once, right? If I leave that right there, that's the touch, right? If I were to move it here, it's still a single location, but that's one location. This is considered a function. In contrast, let's take a look at this. This is a kind of graph you will see sometime this year. It's called a square root graph, square root function, or square root something. Anyways, relation. If I move here, yes, at this particular location, it only touches the curve once. But if I keep moving, ta-da, guess what? There are points on this curve where there are two touches. Because there is more than one possible, so for, let's say, x equals 1, there are two y values. This is a relation. I'll say it one more time. How about this? I think that's self-explanatory. 1, 2, 3, 4, 5, 6 locations for x equals, I don't know, x equals 2 or something. This is a relation. And lastly, same with the circle. Okay? For the x value of when x equals 1, let's say, the y value will be here, the y value will be here. There are two possible y values. This is a relation. Pretty self-explanatory. If I have a quiz question and I say, hey, which one of these is a function, you just smack that vertical line test and you just test it. Okay? Why are we making this distinction? Remember, whether you're working in science or finances or population growth, bacteria stuff, whatever the case may be, like the COVID-19, the looking at a trend of how fast the virus is spreading, all of that. If we put in a certain data point, I want to get out a specific answer. I don't want y could be this, or this, right? I don't want that. I want y. I want y must be this, a single answer. That's why we are talking about functions. We are learning about that math that serves a purpose. Okay? No more relations. We want functions. Any questions? Going once? Going twice? Okay. We're going to come back to these when we start talking about this thing called domain and range. So stay tuned, okay? All right. What is domain and range? Again, we're talking about useful math and being able to describe to people what we're dealing with. Being able to use functions is one way we can make the world of math universal, the language of math universal. There's more to it though, because we need to also be able to describe the time frame or the structure of what we're dealing with. Like for example, okay, let's go up to my idea of money. Remember, if we were dealing with money here, someone give me the answer that they think. What is the smallest number I could have for the category of time in one day? Anyone? What is the smallest value of time I can have?
0.
0. Thank you, whoever that was. Okay. And what is the largest value of time I could technically have in a day?
24 hours.
Yeah, 24 hours, right? And then money, typically, what would be the smallest number that we could have in this scenario when we're working for a job?
$0.
0, and then whatever. Let's pretend you're making like $20 an hour. Then 20 times this, the largest number you could have is 480, right? We need to be able to communicate the lowest and the largest numbers of the scenario we're dealing with. It makes describing and working with people who may not speak English that much more easier. It makes the language of mathematics universal. That's where domain and range comes in. Although the words domain and range might be in English, this symbolism that we're going to learn in just a second is completely universal. It's in just about every textbook. You don't have to worry about overlapping. So here it is. Simply put, the domain is a mathematical word that talks about what are the possible x values. What is the domain of the function is the same as saying what are the x values of the function. Okay? And next I'll do it in red. The range, is a set of points for all possible y values. So if I say, what's the range of this function, I'm talking about how high and low can I go. So with that said, where are my participants at? Mirdoc, you with me?
Yeah, I'm here.
All right. Here is a data set. Okay?
Yeah.
What is the domain of this data set? In other words, remember, if this was a graph,
Mhm.
it'll be like, it'll be something like this. Okay, it'll be
Yeah.
some kind of graph. What is the domain?
So like it's gonna be a straight line, wouldn't it be? Or is that what you're asking?
Nope. I'm asking if this is my graph,
Yeah.
what is the domain? AKA, what are the possible x values of this graph?
I do not know.
I'll help you out.
Would,
This is the
would it
graph.
be those numbers?
Yes. Okay, what about those numbers?
So it'd be 0 and y. I mean, it'll be 0, 1, 3, 5, and I
Yes.
just remembered. Yeah. Okay.
That's it. The domain of this data set is 0, 1, 3, and 5. That's all domain is. You just got to learn this new vocabulary. What about range? Noah?
It's 0, 2, 4, and 6.
Yeah, it's these numbers. Okay, 0, 2, 4, and 6. That's it. Now let's get a little bit more complex here, okay? Here is a graph of points. In other words, they're all disconnected. Let's pretend that's like a 1, that's a 2, that's a 3, 4, 5. Lucas is like, would you be able to say 0 to 5, or do you have to exclude 2 and 4? You would have to exclude 2 and 4, because if you don't, it leaves it open for debate. If you say 0 to 5, people can argue that you are including 2 and 4 in there, right? So in this particular case, you got to be specific. But clearly, Lucas, you're on the same page as me. This is a little annoying. So I'm going to show you a more efficient way to write it just after. I'm trying to get to a point though, so bear with me. All right, here we go. Domain. Aiden, are you with us?
Yeah.
Would you mind telling me what all the possible x values might be for this graph?
-2 to 6.
It's true. But because of these arrows, you can imagine it goes to these numbers too, negative and positive infinity. So how would you communicate that in domain? What would be a creative way you can express that it includes all the numbers from negative to positive?
I'm not sure.
That's okay. No, be creative here. How would you communicate it if this was up to you to decide?
Can I just put like the little two like infinite signs
Uh-huh.
and then just like that?
Just like this?
Well, shouldn't I like? I'm not sure.
Okay, it's fine. I'm just asking, I'm putting you on the spot and asking you for a creative solution. Amina, what do you think? If you are trying to communicate, it encompasses all the whole numbers from negative infinity to positive infinity. How might you communicate that?
I'm not sure.
Not sure? Okay. Do you want to give it a shot? If you were the one who invented this and you wanted the entire world to copy you, how might you write it?
I've been kind of confused. Is it okay if I just keep?
Sure, not a problem. Carson, how would you tell everyone that it includes every single number from negative infinity to positive infinity?
You would go negative infinity to infinity.
Like that?
Sure.
That's not bad, but that's also in English.
Oh, could you do like dots or something?
Oh, okay. So negative infinity dot 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 all the way to positive infinity?
Yeah.
Sure. If that communicates, that's not bad. Maybe you could even do like dot 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 um -2, comma, -1, 0, 1, 2, dot 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 all the way to whatever the case may be. The reason why you might want to specify is, do any of these include decimals? No. So you want to make it clear that even if it goes from negative infinity to positive infinity, you don't include numbers like -1.5. That's not in there, right? So again, going back to Lucas, yo, that's annoying. Isn't there a more efficient way to write it? Yes, there is. But stay tuned. What about range? Charlotte, you with us?
Hi, yeah.
What do you think the range would be? What are the possible y values of this graph?
I'm actually not sure what I would do.
Okay. Here at this. Stay with me, okay? This point is negative 2, 2. That point is negative 1, 2. That point is 0, 2. This point is 1, 2. That point is 2, 2. This point is 3, 2. That is 4, 2. That's 5, 2. And this is 6, 2. What are the possible y values?
2.
2. Yeah, that's it.
Okay.
Yeah, with me, right? All right. I'm going to clear this and we're going to go to the solid lines. Carson, I'm coming back to you. Okay? I'm going to come back because you did that domain for me here. What if it was a solid line? Actually, Charlotte, what's the range of this if I asked you right here?
2.
Yes, it's still 2. Okay, Carson, what's the domain?
Um, uh, would it be an equation for the line?
Uh, oh, that's not a bad thought. You're overthinking it though. It's still from negative infinity to positive infinity. What's the difference between the previous example and this one?
The points aren't specified.
Right. In other words, it's not just the whole numbers, but all the decimals in between. Now maybe you can do this. Right? Or you can be like negative 0.9, negative 0.899, all the way to 0, to 1, to 1.01, to 1.011. It gets pretty annoying, doesn't it? But there's got to be a better way because I always say that mathematicians are
Lazy.
lazy. We don't got time for this, right? We don't have time for that. So there must be a more efficient way to do it, and there is, but to do so, we need to adopt a couple of symbols. Symbols that are universally accepted. Okay? To be completely clear, to write the domain of this line, I would say x belongs to real numbers. That's how we would write it. And if I write this, any mathematician would be like, oh, I understand what you're saying. Dude, right now, you have no idea what the heck all this is because you've never seen it before. So let's learn how to use this language together. Okay? Any questions before we learn our new language? No? Any questions about, well, maybe you'll get back, we'll get back to it. Maybe we'll get back to it when you feel a little bit more comfortable asking a question. All right. Here we go. What are these funky symbols? Well, there are special symbols with important meanings in the mathematical world. You have to commit these to memory if you want to use it properly. Okay? Set brackets. So when we start talking about domain or range, it's always going to be encompassed inside these squiggly brackets. Please have that to memory, or please copy that down. Next, you will be talking about whether x is equal to or bigger than or smaller than, so we have to introduce inequalities, and that goes to your elementary middle school where you're using alligator mouths to figure out whether something is greater than or less than. Some people don't like this because they just had such trouble when they were kids. If that is you, I'll try to give you some strategies later on, but largely, you might want to think about this as like a mouth of like Pac-Man, you know, and Pac-Man wants to eat the larger number. So what I mean by that is, let's pretend I have 7 versus a negative 7. Clearly, 7 is larger than negative 7, and so we draw my Pac-Man eating this way, right? So thinking about keeping Pac-Man in your head, that's the mouth. If you don't like that and you always got confused, think about it another way. Between 7 and negative 7 is smaller. We always point our arrow towards the smaller direction. Like it's an arrow, right? Like you can think about it that way. Whatever the case may be for you, you have to commit it to memory and not make a mistake. Next, when we describe domain and range, you will use the word such that. This is sort of like the condition, right? Under the condition that, such that. And that is just a vertical line, sort of like a barrier separating two different sections. Okay? Just a vertical line. You even have this in your computer. I don't know where it is for you, but take a look. It's part of every keyboard, so you might be able to find it somewhere. Right? Anyways. Next, belongs to or is an element of. You've just seen me use this. It is E. It's an epsilon. It's a Greek Latin letter. It's Greek letter, and you will see that often. When you see this as part of a domain and range, it simply means it belongs to a family of numbers. What family of numbers? The example above, I used the letter R. That represents real numbers, and which means basically all decimals included. And integers is I, okay, non-decimals only. In some textbooks, you might also see it written as a Z. Originally, I believe they did use the letter Z. Maybe the letter I was used for something. I don't have enough knowledge to tell you why it was Z to begin with.
I was used for imaginary numbers.
Ah, that's why. Thank you. Those are
That is
complex
the first
numbers.
letter of the German word.
That makes sense. Okay, so textbooks nowadays just use a bolded I now, but if you get your hands on a slightly older textbook or even university textbooks, they are true to, what do you call it? True to the original, and they have like a slanted I, so they use a Z. For our purposes, you can use either one. I will accept either because we won't be touching on imaginary numbers too much. Okay, unless you're gifted, but that's a different story. So you might be asking, what the heck is a real number? What the heck is an integer? This part right here that I'm doing is not tested. This is for your own knowledge only. So let me go through this, and then once we do it, we'll practice some domain and range, and then we're done for today.
Do we need to know when to use them and what they mean, or just like the symbols?
We will use them, so you'll see them in action very soon. Okay, so this is just for an FYI. I wanted to share this because I think it's pretty cool. The world of math and the world of numbers is pretty crazy. It's very, very in-depth. Who's on my list to pick on? Carson, Charlotte, Kiara. Kiara, when you were born, what is the first number you learned? No? Kiara, you're not with us? Okay. Claire, are you with us? Claire, going once, going twice.
Yeah, I'm here.
Okay. When you were a child, like 2 years old or whatever, what are the first numbers that you learn?
I don't know.
What's the easiest number?
1.
Yeah, well, typically you start learning numbers like how old are you, and you're like twee, right? Like it's stuff like that. So you learn 1, 2, 3, and you count as high as you can to make your parents so proud of you because my child is a genius, right? It's always like that. This group of numbers is called the natural numbers, aka this n with a double bar. I don't know why it's always double barred, but maybe it's just a symbol to show that it's part of the group. And then afterwards, Emily, I'm coming to you. After you learn 1, 2, 3, 4, all the way to infinity, you learn another concept. Like, I have 1 cookie. I have 2 cookies. And then Emily, you're like, oh, I'm sad because I have.
I I don't know.
What happens when you eat the cookie?
It's gone.
It's gone. So how many cookies you got?
None.
None. The next group of numbers is called whole numbers, or W with the little bar, and that includes the number 0. Okay? So after natural numbers, you get into whole numbers. And what's interesting is that even computers understand this if it's programmed. So you can define and use coding, and if you're into apps, or you have a goal set to become like go to Silicon Valley and make millions, okay? Whole numbers is from 0 to infinity. And then after 0, when you're in middle school, you learn the concept that you could go lower than 0. You can go as far left on the number line as you want, as you can go right of the number line. Right? And this is integers. And that is the letter Z. But you can do I. I don't mind that. I don't really care. Okay? Purists will think I'm sacrilegious, but yeah, don't worry too much. Then outside of here comes real numbers. Real numbers basically encompass everything from negative infinity to positive infinity, all decimals, doesn't matter. What comes in between? The stuff that come in between are numbers that can be written as ratios, aka fractions, but they can't be written as decimals. For example, this is called irrational numbers, and the letter for that is Q. Okay, rational numbers like I don't know, it could just anything like 1/4. Of course, you can also write 22/7. So decimals count here too. 22/7 is as close to pi as we can get. So we can still write it as a fraction, it just we can't quite see the end of it. Anyways, that's rational, and there's real. Amongst them, there are numbers that are part of the real family, but are not part of the rational family. They are numbers that are decimals, but you can't write it as a fraction, and you also don't see an end. What is that? Those are the irrationals. And that is not rational. So there's a rational symbol with a line above it. It's not. They are numbers like square root of 2. We don't know what the end is. They are numbers like pi. We don't know what the end is. Euler's constant E, which you might see in math and sciences when you get to grade 12 and university and beyond. Okay, the list goes on. Question? And then there's another bubble underneath, but I forgot to move the graph, so it's gonna get messy. Yeah, there's a little bubble underneath that, which I'm gonna just draw here. There's a set of numbers that don't fit in the real number. They don't belong in here because they're not real. They are complex or imaginary. And that has the letter I to it, to be honest. And that is numbers like, I, which is equal to square root of -1. Right? It's imaginary because you can't do a square root of a negative number, but if in some parallel universe we could, the applications of that would be incredible. We could solve a lot of interesting mysteries using math if that was possible. That's why there's applicable math, like applied math, and theoretical math, right? Anyways. That's a little thing for me. I sort of get excited and talk about that because it just shows just how deep math can be in something as simple as this. But remember, this is you're not going to be responsible for anything other than integer and real numbers for any time in the future. Okay, just integer and real numbers. Stopping right there, I'm going to go and start showing you how to use domain and range, these symbols for domain and range. Any questions about this before we get started?
Yeah, I just have one question. How do you write the irrational symbol?
Irrational is a same Q. It's a Q with a little bar inside it, and there's a line on top saying it's the opposite of Q. So this is rational. Irrational would mean that. Not rational. That is sort of like saying not. Okay? Small detail, not really important right now. Any other questions? Okay, let me clear this. Let's go back. Let me go back to our original example here. I'm going to show you how domain and range can be applied. So for this one, domain, okay, I'm going to start with a squiggly. Domain is talking about all the numbers going left to right, so I'm referring to my x values. All the x values belong to integers or real numbers. What do you think? Who can I pick on? Gemma, what do you think?
I don't know.
Well, I'll ask you this instead. Does this straight line look like it's only talking about the whole numbers, like the non-decimal numbers, or do you think it includes all numbers, including 0.1, 0.2, 0.3, and so on?
Since it's a line, maybe it includes all of them.
So if this is a 1 and it's a 2, 1 is right here, 2 is right there, but it includes all the numbers between 1, 2, and 3, and so on. It includes a decimal. Long story short, it's a solid line. When you see a solid line, you can safely say it belongs to real numbers. All right? Harriet, you with me? How far left and how far right do you think this line goes?
It goes on forever.
It goes on forever. So do you think there is a limit to it?
No.
No. Then I don't have to say such that. I can just close this and say I'm done my domain. I've told everyone that any value from negative infinity to positive infinity is okay. Range. Helen, are you with us? Sort of?
Hi, yes.
Oh, okay. So for range, now that we're looking at top and bottom, like up and down, what variable do you think we're dealing with?
I have no clue.
Well, it's not x.
Why?
It's going to be y. And because it's a solid line, we know that it involves all the y values, including decimals. And that's it. All right. Now this one's going to be a little bit of an annoying one. It doesn't serve our purpose of practicing domain and range. Let's move on to this one. We're talking about domain here, and of course I'm dealing with x. Jonah T, are you with us?
Yeah.
Okay, so Jonah, x, do you see this? Do you think it's real numbers or integers for this parabola?
Would it be integers?
The question you want to ask is it a solid line or is it dots?
It's a solid line.
It's a solid line, so it would include the decimals. What group or family of numbers is that?
I don't remember.
That's a tough one. Okay, it's going to be x belongs to real numbers. because it includes all the decimals. Okay? Is there a restriction? Is there a wall somewhere and the x can't go any further? This continues on forever and ever. Josh F. Josh? Going once. Nice. Kinda, you with me?
Yeah.
Do you think there is a do you think there's a limit to how far I can go? Or
No, I think it goes to infinity.
if you're going to infinity, then I have no restrictions. Good. But what about the y value? Let's pretend that's a -1. For my range, y still belongs to real numbers because it's a solid line, such that... Kinda, what do you think?
I think it goes from -1 to infinity.
Good. You're right. It can go to infinity, but it has to be bigger than or equal to -1. So you say, well, that's when you use an inequality. I'm going to write -1 is going to be smaller than or equal to my y value. Y value is always bigger or equal to -1. So you write it like this. That's my condition. Okay, let that sink in. Y belongs to real numbers because it's a solid line, and y has to be bigger than or equal to -1. Okay, let's do one more. I'll do it on my own, and then I'm going to ask people to just try the last one before we dismiss. Okay, let's pretend this is a -2. That's all I really need. Okay, Lucas, can I pick on you?
Yes.
All right. I'm talking about domain. Which variable does that refer to?
The x.
X. And it belongs to what family of numbers?
The real numbers.
Right on, because it's a solid line, it includes decimal. Do I have a restriction, or do I have a limit or a condition?
Yes, -1. So.
Right. Oh, yeah. Okay, sure. Let's pretend that's a -1 or 2, whatever.
Oh,
So
sorry.
it goes to positive infinity, but it has to be bigger than or equal to
-1.
-1.
So
So I'm
since
going to
that
say,
-1 is less than or equal to x.
yeah, perfect. Done. What about range?
Um, I'm gonna give it a shot because like, okay, my reasoning here is that like a parabola like that is technically infinite, but
Yeah, let's pretend it continues on like this forever.
okay. So then it would be y belongs to real.
Right on.
And I think that's it.
Yeah, there's no restriction. So we just close it up. Nice. Okay, I'm going to add some numbers here. Let's pretend that's a 5. That's a -1. That's a 1. And that's like a 6 or something. That's -1, -1. Okay, everyone, attempt it. Give me the domain and range of this circle. It's a relation, but that doesn't mean you can't tell me what the domain and range is. I'll give you 1 minute because that's as far as how much time we have in class right now. All right, let's test it. Someone want to give it a shot that maybe was a little shaky at first, but want to confirm now. Anyone?
I'll go.
Yeah, go Simon, go for it.
Would it be so X belongs to real numbers,
Yes,
and then the line
such that, yep.
yeah, it's like that. -1, and then would you put another line, or would you just put like a comma with the
No,
6?
you're basically writing a statement, putting an inequality with X.
So 6 too.
Yep. Okay. Let me give you a strategy. So what's the smallest number possible?
-1.
What's the largest number possible?
6.
6. So put a -1 and 6 at the edges, and you're putting the X smushed between the two, which sort of makes sense, right?
Okay.
The entire X value has to be between 1 and -1 and 6. X is going to be bigger than or equal to -1, and 6 is going to be bigger than or equal to X. Visually, does that make sense to you?
Yeah, it does.
Yeah. Can you try the Y then? The range?
Okay, so same thing with the belongs to
Mm-hmm.
real, and then such as -1,
Mm-hmm.
then equal to or less than.
Yeah, less than or equal to.
And then the Y in the middle,
Mm-hmm.
and then the equal to less than 5.
Good. Perfect. That's it. So instead of saying it in English or typing that entire sentence in English or trying to describe a domain and range using a paragraph, just because we learned how to use symbols, we can communicate universally to the rest of the world the limitations of whatever function we're dealing with. And it comes useful, especially when we get to things like in advanced functions in grade 12. So we're going to learn it. Every time we draw a graph or do something with the graph, I might, on a whim, be like, hey, what's the domain? Hey, what's the range? And I expect you to be able to use these symbols. So you don't have the textbook with yet. You're going to get it on Thursday and Friday. That's basically chapter 1.1. Please take a look at the Waterloo stuff and try to practice your function notation. I believe that it's there with domain and range. I haven't triple checked. I'm pretty sure it's there. If not, we'll get a chance to revisit it when we look at when you get your textbook. Okay? I already kept you for 3 minutes too long. Please, you are dismissed. Please have this sheet handy. I already have these printed for you in class, and you can get it or pick it up on Thursday. But as you can see, I'm just constantly annotating it and writing over it. It might be useful to print it out anyway. If you don't have access to that, don't worry. Just keep note of it. You know, this is going to be recorded, so you can always go back and take a look. My answer key and the sheet that I annotated physically by hand is already posted online, so you can double check with that too. Okay? Any questions? People who do have questions, just ask away right now. Otherwise, you are dismissed. Go take a break. All right? I'll stay here for a couple of minutes for questions.
Thank you.
Have a good afternoon.
Bye. Stay safe.
Bye.
Mr. Kim,
Yep.
for like the funky brackets, is there like a specific way I have to draw them, or can I just draw them like kind of like that? Because I don't know how to like make them, and every time I draw them, it kind of looks different than the previous ones.
Do your best. Some people, like even some teachers that I know, they just draw 3 and 3, reverse 3 like a butterfly. It is what it is. Some people are able to draw it in S's. Here's one S, and then they reverse the S. Right?
Yeah.
Whatever works for you, but do your best to just keep on practicing until it sort of comes a little bit more naturally to you. Okay?
Okay, sure. Thank you.
I'm not gonna flack you on. Yeah, don't worry about it, but do your best.
Okay, yeah. Thank you. Bye.
See you later.